Hey everyone, this is lesson 13 in Calculus AB, and this is derivatives of inverse functions. All right, so first off, this is the formula that we're going to look at here. Okay, so formula for formula for the derivative. Oh my goodness, of an inverse is right here. All right, g prime is equals to 1 over f prime of g of x. All right. And so let's just say we have two functions, f and g, and that they're inverses of each other. You might remember this from your pre-cal days, but f of g of x is equals to x and g of f of x equals to x. Then that makes these two functions inverses of each other. Well, what if I wanted to derive this combination right here? I would have to use a chain rule, right? And that would be the derivative of the outside, copying the inside, times the derivative of the inside. So if my two functions are f and its inverse g, and I wanted to take the derivative of that inverse g, right? I'm basically trying to isolate this g prime, okay? So set it equals to x, and I'll derive this x, which is 1. Now, I just really need to divide by f prime of g of x to both sides. And just like that, we get rid of this. And then you can see here g prime of x is equals to 1 over f prime of g of x, okay? And that's what we see here, right? Obviously, I put the parentheses there because it looks a little nicer. All right, so if you see these questions on the AP exam, they tend to not be calculator active, so we're going to try to get through most of these without the calculator. All right, so let's start doing some of these examples. Find the derivative of the inverse at the indicated x value. So here we have a function, right? X cubed plus 2x minus 1. We'll just call it f, right? And we want to find the derivative of the inverse at x equals to 2, basically, right? So basically what we're looking for is g of 2. That means that's what we're looking for, right? Which really means we're doing 1 over f prime of g of 2, okay? And so this means that we need to figure out what g of 2 is, okay? Now, let me start by making a little f of x table here, okay? And I'm also going to make a quick little g of x table. And again, just g is the inverse, right? Okay, so if we know that x value is 2, I'm actually going to put that 2 right here. And whatever number we get here, if you think about what was the idea behind an inverse function in pre-cal, we always swapped the x and y's, right? So that means that if for this inverse function, x is the 2 value, well then that means that was really the f of x value over here. And then we're going to use that to figure out the x value, okay? So let's start by taking our f of x function and setting it equals to 2. All right, now I got to solve this, right? So I'm going to make it equal to 0. I'm going to move 2 to the other side, which means minus 2, which really just means I end up with 2x minus 3. All right, we need to try to solve this. But this looks like it's going to take us into that rational root theorem, that P over Q, okay? And so that's going to turn out to be, let's see, factors of -3 plus or minus 1 plus or minus 3, factors of this 1 here, just plus or minus 1. So these are the possible factors. Now, I have bad news. You have to do this. But the good news is the numbers that emerge for the inverse here, they tend to be between -2 and +2. So you really don't have to go too far down the road. For obvious reasons, I think we're going to start with +1 and go with synthetic division. All right, so using our polynomial here, that's going to be 1. We're missing x squared, so we're putting a 0. We got 2 for that x term and -3. All right, bringing down this 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. 2 plus 1 is 3. And 3 times 1 is 3. And we did get a 0 here, so that's great, right? And that means that 1 is the number that we want. And so if it's an input here, it's an output over here in the inverse. That means now we know that when we plug in g of 2, we're going to get 1 there. So far, we got our answer to be 1 over f prime of, when we plug in 2 into g of x, we're going to get 1. Okay, so that means that now I need to take the derivative of this f function and plug in 1. So let's do that. Let's take the derivative. That's f prime of x, right? And that's going to be 3x squared plus 2. And now, if that's my derivative, all I got to do now is basically plug in 1. So f of 1, I'm sorry, f prime of 1, that's going to be, let's see, 3 times 1 squared is just 3, plus 2 is 5. So that's the denominator here. So we're going to get that g prime of 2 is 1 over 5. All right, so that's how this works, okay? All right, we're going to do a few of them. Let's try this one. This one here is f of x equals 2x to the 5th plus x cubed plus 1. We want to take this at x equals 4. So that really just means we're taking the inverse and plugging in 4, right? So that, remember, is 1 over f prime of g of 4. So we need to know what is our g function when we plug in 4, okay? So feel free to start that way, right? Which means that that's the output for the f of x function. All right, so let's do it. If that's the output for the f of x function, I'm going to replace that f of x for 4. So 4 equals 2x to the 5th plus x cubed plus 1. All right, so minus 4 on both sides. And we get, let's see, 0 equals to 2x to the 5th plus x cubed. Minus 4 is minus 3 over here. Ooh, and we got to do this again, right? So the p over q ends up giving us plus or minus 1, plus or minus 3. Those are the factors of negative 3. Factors of the leading coefficient. Factors of the leading coefficient. That's plus or minus 1 and plus or minus 2. Okay, so when I start dividing all these things, I get my possible roots to be 1 over 1, right, which is 1. 1 over 2, which is just 1/2, right? Okay. Now I move on to 3 over 1, which is 3, and 3 over 2, which is, well, 3/2, right? Okay, so I'm going to start with the easiest one, start with positive 1, and we're going to do this with synthetic division again. We're looking for that remainder of 0, okay? All right, so here's our polynomial. Let's go 2, right? We're missing the 4th power, so we're going to put a 0 there. There's a 1 there. Okay, we're missing the power of 2. We're missing the power of 1, so zeros all around there. And then we have our constant of negative 3. All right, so synthetic division. 2 times 1 is 2. 0 plus 2 is 2. 2 times 1 is 2. 1 plus 2 is 3. 3 times 1 is 3. 0 plus 3 is 3. 3 times 1 is 3. 0 plus 3 is 3. 3 times 1 is 3. And there's that remainder 0. Awesome, right? Couldn't have worked out any better, which means we're going to throw a 1 in here, and we're going to put a 1 right here. So that's great, because if we do g of 4, that means we're getting 1. So this is really 1 over f prime of 1. Okay, so again, we'll take this f function and we'll take its derivative, okay? So what is the derivative? Well, that's a power rule. So that's 10x to the power of 4 plus 3x squared. And then now we just plug in 1, right? 1 to the 4th power is 1. So that's just 10. And 1 squared is just 1. So that's 3, okay? Which gives us 13, okay? So we end up with an answer here of 1 over 13. And that's our g prime of 4, okay? This is our final answer. All right, kind of a lot of work, but you can see that if we're moving with a rhythm, we can get it done in a couple minutes. All right, let's do another one. Question number 3, f of x equals square root of x minus 4 at x equals 2, right? What's the derivative of the inverse? So what's this guy, right? So 1 over f prime of g of 2. All right, so, well, let's find g of 2, right? If I plug in 2 here, what's that output, okay? Well, if they're inverse functions, g and f, that is, that means that if this is the input, positive 2, sorry, then this is the output over here on f of x, right? So I'm going to go ahead and replace my f of x there with a 2. So this is 2 equals the square root of x minus 4. And certainly this one looks really easy, right? Well, how do we get rid of the square root? We just square both sides, right? That'll get rid of that. And then we end up with x minus 4 equals to 4. Now, oh, I could just add 4 to both sides, right? That's easy. And we end up with x equals to 8. That was fast, right? So x equals 8. So they're not all like nasty, you know? And then we get an 8 over here, right? If that's the input for the original function, well, then it's the output for the inverse. All right, so G of 2 is going to be positive 8. So I'm going to replace that right here in the formula. So that's 1 over f prime of 8. And you see how I didn't have to do p over q? So whenever the number is like, that's not a nasty number, but whenever it's larger than like 2, it's typically another format for solving for x, okay? All right, let's take our derivative. So the derivative of f of x is equals to, well, let's change the way that's written, actually. That's going to be x minus 4 to the power of 1/2, and I'm going to go ahead and do a chain rule on this, okay? So derivative of the outside means move this to the front, right? Copy the inside, and then times the derivative of the inside, which is just going to be 1, right? Anytime we see a square root there with a negative power like that, we can just move that to the bottom. So that's going to be, let's see, 1 times 1, that's just 1 on the top, 2 on the bottom with that square root of x minus 4. And that's the derivative. And the reason why I wanted to write it like this is because now I need to take this derivative and I got to plug in 8, you see? So let's plug in 8. All right, so that's going to be 1 over 2 times the square root of 8 minus 4, right? And so that gives me 4 in there. Square root of 4 should be 2. And so we end up with 2 times 2, which is, of course, 1/4. Because I almost put this as my answer. This is really 1 over 1/4, right? So when we simplify this, our final answer here turns out to be 4, okay? So this is the final answer for this g prime of 2, all right? You had to manipulate that a little bit at the end. All right, let's look at a couple other scenarios that we might, encounter. I'm actually going to skip this one. Let's do some trig questions, all right? Some trig questions just so we can refresh our memory a little bit, right? Okay, so I know I'm going to want to set up my table, so let me just get that going. And if I have to find the derivative of the inverse function, that means I'm finding g prime of 1/2, all right, which is 1 over f prime of g of 1/2. All right, so here we go. If x is 1/2 over here, that means that this is the output over here and for f of x. All right, so I want to just take 1/2 and plug it in there for f of x. That's 1/2, which is equals to sine of x, right? And then I just got to think, hey, where is sine of x equals to 1/2? And keep in mind the restriction that we have from negative pi over 2 to pi over 2, right? Negative pi over 2 is over here, and pi over 2 is over here. So that means we're working with this region right here, okay? And so the only place where we have a positive sine value would be like a positive y value, right? That's up here. And anyway, 1/2 for the y value there, it's going to be at pi over 6. So x equals pi over 6. All right, so we got our x value there. And that means that sine of pi over 6 is 1/2, by the way. Okay, so now that we know the x value for this function, that means that this is the output for the g function. Okay, so if you were to plug it in here, you can, right? Oh, I'm kind of running out of room, but that would mean that we get 1 over f prime of pi over 6. And what that means is that we want to take our derivative and plug in pi over 6. So now let's do that. So let's take our derivative. Derivative of sine is just cosine of x in this case. And then if we were to plug in pi over 6, so cosine of pi over 6 is radical 3 over 2. Okay, so that's what we replace right here. And so we end up getting 1 over radical 3 over 2. And just like the last one, we would do the keep, change, flip. And we end up getting 2 over radical 3. There's no need to simplify these. Remember, in calculus, we really don't have to do that, okay? So feel free to leave your answer like this. Okay, so let's keep doing another one, okay? Here we have the same restriction there, which goes from negative pi over 2 up to pi over 2 right here, okay? And we want to find g prime of 1, okay? And so remember, if we're finding g prime of 1, that really just means we're doing 1 over f prime of g of 1, okay? So that means that when x is 1, that means that the y is 1 on the f of x function, okay? So I want to write that down. So when x is 1 over here, that's when y is 1 over here, right? These are inverse functions. Okay, so I need to find when is this function equals to 1, right? So this is going to be 1 equals tangent of x. And if you recall, tangent equals to 1 at pi over 4 on this values right here, okay? So this is going to be x is equals to pi over 4, all right? Okay, so now that we know that x is pi over 4, we can fill that in, right? That's pi over 4 here. And that means that in my little formula here, I'm just going to go plugging everything in. That's f prime of g of 1 is pi over 4. And that means when I take the derivative, I'm just going to plug in pi over 4. So I want to take the derivative now, right? Well, what's the derivative of tangent of x? Secant squared of x. Very good. And then that means I need to now plug in pi over 4 into that derivative. Okay, so if we plug in pi over 4 into that, remember that, by the way, remember that secant of x is really just 1 over cosine of x. So if we know that cosine of pi over 4 is radical 2 over 2, secant is the reciprocal of that, which would basically be 2 over radical 2, okay? So that's how we can come up with that. Now, I do want to square this, though. Go ahead and put a square here and just kind of simplify it from here. Well, we know 2 squared is going to be 4, radical 2 squared is going to be 2, and of course 4 over 2 is 2, okay? So that's what I can plug in here for this f prime of pi over 4. So that means I get 1/2 for this value of g prime of 1, okay? 1/2, that's my final answer on that, okay? All right, let's just do a few review questions now. A couple things just to review, not even related to the section, okay? All right, so let's make this bigger. Can you approximate f prime of 2 using the table? So this would be like a numerical representation of a derivative, right? F prime of 2. So I know that 2 falls in this range right here. That's where the x value of 2 falls, right? And so since we know that a derivative is just really slope, I could really just do change in y over the change in x to figure this out, okay? So let's do that. This would be 6 minus -2. That becomes 6 plus 2 over, and then I could do 3 minus 1, and that becomes 8 over 2, which is, of course, 4. Okay? That means that f prime of 2 would be equal to 4. Now, this is just an approximation, so keep that in mind. But this would be like the best estimate, okay? All right, here's another one of those. Another one of those questions, g prime of 3. Well, we know that 3 falls within this range, right? Okay. This is not inverse, by the way, because if you notice, a g is given right here. This is really just slope, okay? So what we're going to do here is we're just going to say that this is the change in y over the change in x. And so 8 minus 3 over 5 minus 2, and that's 5 over 3, okay? That's how we can come up with that value. All right, so not too bad. All right, let's do a couple other questions. Again, not related to this section at all, just to review a couple things, okay? The graph of the function of f of x is equals to ax minus b over x plus c. It has a vertical asymptote at x equals -5 and a horizontal asymptote at y equals -3. So find a plus c. All right. Okay, so in rational functions, if you recall, when you have a vertical asymptote, it's because you had a factor that was left on the bottom. Okay, so if we have a x equals -5 as a vertical asymptote, that means that the factor that comes from that is x plus 5. That means x plus 5 is sitting down there on the bottom. Okay, which means that c has to then equals to 5. All right, with that being said, we also got to find a, right? Where's the thing about the a? Oh, it talks about a horizontal asymptote, right? Well, when do we have a horizontal asymptote? Well, if you recall, when your function's bottom heavy, then you have a horizontal asymptote at y equals 0. If your function is top heavy, there's no horizontal asymptote. But if you have a horizontal asymptote that equals to a number like this one, y equals -3, it's because you have something over something as a leading coefficient, and it somehow gave you -3. Now I see a 1 here in the front, so that means that this a value has to then be -3, because -3 over 1 has to give us negative 3. Okay, so that means that a is negative 3. So the question is, find a plus c. So a is negative 3, and c is 5, and negative 3 plus 5 has to be 2. Okay, all right, so that's good. Hey, that could even be a little SAT prep. And then I have another one just like that, but I think you're good with the one we did. I do like this next question. Find all vertical asymptotes of the graph. Could we factor this trinomial in the numerator, right? And we can. If we factor this trinomial in the numerator, we would get two factors, right? We'd get x plus 2 and x plus 3. And then in the denominator, look, if we could take out an x right off the bat, right? And then this would become x squared minus 4, all right? That's what that is equal to. But then this right here is still a difference of squares, which means I can continue to break it down. So I'm going to get x down here. I'm going to get x plus 2, and I'm going to get x minus 2. That's how you factor a difference of squares. Okay. Now, once we have this whole thing factored out, r of x, could we find the vertical asymptotes? And we just talked about that being any factors that remain on the bottom. Well, if we remove this and we remove this, by the way, those removable pieces, those are the holes, okay? Well, the only thing that's left in the denominator is x equals 0, right? It comes from this factor here, and also this factor here, right? X minus 2. If we set that equals to 0, don't we just get x equals to 2? And those two equations there, those would be your vertical asymptotes, all right? Okay, so good little review there on just a couple things that would be important down the road, and just things that you should always kind of remember, okay? All right, so that wraps up lesson number 13. Hope it wasn't too bad. And all right, that's derivative of an inverse function, everybody.